Thank you so much. My name is David. I am coming to you from Chicago, Illinois, in the United States, and speaking to my friends here in Romania, a country that I've visited many times, and I really enjoy both the country and the people. I'm going to talk today about data, specifically about two related tools: Azure Data Explorer, which you'll often hear me refer to as ADX, and the query language associated with that, Kusto Query Language, and I'll often abbreviate that as KQL. This is me. I work for Microsoft. I've got some online presence here, my blog at davidgiard.com, a couple of TV shows. One of them, Technology and Friends, is interviews with smart people about technology, and the other one are screencasts of how to do certain things in brief screencasts of how to perform tasks in Azure or related tools. They're both available online. Check them out, please. Here's our agenda. I'm going to talk about Azure Data Explorer, what it is, why it's useful, when you should and when you should not use it, how to create the infrastructure around it, and then I'll talk about KQL, Kusto Query Language. I'll start with the basics because I'm assuming a lot of people don't know this language yet, and then I'll show some examples of how to use it with time series data. It's really useful with time series data, and some of the useful functions that are built into it. The ones that we've been using on my project are the geo functions that are built into there, and then some optimization things, including materialized views. And then I'll also explain why there are pictures of scuba divers on each of these slides. So stay tuned. All right, Azure Data Explorer. It's really designed for massive data storage. And when I say massive, I mean petabytes of data, enormous amounts of data. It's been used by Microsoft for a long time internally. It's recently become a product for external use. And it's been tested and pounded on for large data sets. It's very fast. It works with structured, semi-structured, or unstructured data, any of those things. It's massively scalable because, of course, it's in the Azure cloud, and so you can scale it up or scale it as you want. And it is a managed service, which means that it abstracts away from you, the developer or the DBA, the things like the what I call the plumbing, the hardware and the infrastructure and the connectivity. All of that is managed for you. If a server goes down, then there's some redundancy built in, and it'll take care of that for you. You don't have to manage that. So it's less headaches for you. You can focus on your data, your queries, and your application. This flowchart talks about when to use ADX and when not to use it. I won't drain it. I copied and pasted this from Microsoft documentation with the tiny URLs on the slide right there. But essentially, it's great for huge amounts of data that you want to query in near real time. That's really where it excels. If you want lots of data stored and you want to get to it fast, that's great. If you want something like a data warehouse, like a star schema, probably not. You probably want to look at some sort of specifically a data warehouse solution. If you want to look at, it doesn't support anything like ETL transactions. That's not part of the product. There are other products inside of Azure that'll do that, and that's great. And also, if you wanted to run the same database on multiple cloud platforms, right now this is only supported on Azure. So if those are your requirements and you absolutely have to have them, there are other solutions for that. But if you want massive data storage and really fast query times with lots of flexibility and built-in functions, this is for you. As I said, it's actually been around for a while internally at Microsoft. It's used for things like the Microsoft Office telemetry. So if you ever install Word and there's a little pop-up says, "Would you like to improve the experience by sharing your metrics with Microsoft?" If you click on that, it sends data back to Microsoft about which features you're using and how you're using and whether the product crashed or anything like that. All that is stored in ADX, which is, if you imagine, a popular product like Office, that's a massive amount of data. Azure Monitor and Azure Application Insights, that's just monitoring everything that's going on in Azure. Again, huge amounts of data that are being stored in there. So for years, internally, the Microsoft team has been using this product and testing it and finding the warts and fixing them and so on. It's been available just for a little while, I think about a year and a half. I'm not sure of the exact date, but now it's a product that's available to other folks through the Azure portal. So here's some companies right now that are using it. I think LinkedIn is now part of Microsoft, so that doesn't really count, but they started that, I think, before they were part of Microsoft. So those are some big companies using it. Um, here's the structure of an ADX cluster. Everything starts at the cluster. A cluster is just one or more server nodes in the cloud that are managed for you. You create that cluster, and within that cluster, you can create one or more databases. With each database, you can have tables and views and functions and other assets that are related to that. A lot like a database like SQL Server or Oracle or MySQL. They're structures similar to this. I'll show some demos of this in a bit, but here's a screenshot of how you create a cluster in Azure. It's dirt simple. You can click on a button, say add a new cluster, and give it a resource group, which is a logical grouping of resources that you can manage together. Um, give the cluster a name, a unique name. Tell it the size of the machines in that cluster, and the compute specifications down at the bottom will actually give you options. If you say you want optimized for commute or optimized for storage, it will suggest options that are ideal for that, and you can get more specific. This is really all you need. There are other options here to specify exactly how much you want to scale it, or whether you want to do auto scaling, some security information, and so on. But this will give you enough. And click that and create a cluster. And once that cluster is created, then you can go inside and create databases. Again, dirt simple. Give the database a name. You can specify a retention policy. So if you don't want to keep data around forever, you can say after a year, delete it. You can check this box to say keep it forever. And the same thing with caching. How much do you want to cache? You'll need more compute power if you want to keep things in memory for a long period of time, but you have options to configure that depending upon your needs. And then you have in your portal, you've got we call this a blade, an interface for managing this portal, and you can start creating your assets in there. For example, tables. Tables are really important. I should point out that all of this creating of a cluster and a database, that can be automated. Things like ARM templates can be used to that, or you can write Bash or PowerShell scripts to do that as well. That's all supported. Using commands within ADX, you can also automate the creation of a table. You can do that through the portal as well if you want. But there are commands to create a table. Create merge basically says if the table already doesn't exist, then create it, otherwise don't. Dropping the table, changing the columns, and so on. There's a whole series. You can see if there's an example of how to create a new table here called customers with these columns in it. So there is actually some schema associated with this. So it's semi-structured, but there's not necessarily enforced relationships between tables, which makes for data insertions a lot faster. When you want to get data into it, there are multiple options. You can pull data out of Azure Blob Storage. There's a single command to do that. So if you have got a large CSV file in Blob Storage, you can pull that right in. You can write a query to ingest from another table. You can do streaming ingestion, which is what we're doing on our project. We push data into, we have IoT devices pushing data into an event hub. And then every time a bit of data is pushed to the event hub, it automatically gets inserted into an ADX table. Oh, this is a build slide. I forgot. There we go. Storage, query, event hub. That's my magic, my PowerPoint foo right there. And then, of course, you can inline if you wanted to just insert a bunch of rows. You can code them like this: ingest into table, customers, and here I've ingested all the visionaries of the last 30 years here: Bill, Steve, Satya, Steve, Larry, Jeff, Tim, Steve, Scott, and me, because it's my presentation. All right, let's show a demo. I'll go back over here. This is the Azure portal. You can go to portal.azure.com. If you don't have an account, then you can get a 30-day free trial. That's available on here as well. But within the portal, the way we create just about anything is this big blue plus where it says create a resource. I do that, and then I could search for Azure Data Explorer right there. Oops. There we go. Create a new Azure Data Explorer cluster. Click on Create. And this is where I showed you the screenshot. I can specify a resource group. I can create a brand new one. I'll call it Romania Codecamp RG, like that. And cluster name, Romania, CC cluster. How about that? Put it wherever I want to. You probably want to put it close to where your users are, or maybe close to if it's ingesting some data automatically close to that. Think about that. I'm in the US, so I'll specify that. And the workload development dev test will create a small one. It's probably not great for production, but if you want to learn it, it's a lot cheaper. And it'll suggest these things right here, the size of these machines, or you can get bigger ones that are optimized for storage, computer, heavy compute, really big ones. And you can specify, more than that. If I collect one here, it's going to large, just go heavy. Here, availability zones for where do you want this redundancy to happen in different parts of the world. And here, if you want to go click on review and create, it'll go right over here. It'll validate, make sure that you haven't missed anything or have anything inconsistent. But you could also go in here and specify if you want to do, for example, auto scaling. You could turn that on or turn on some security on here. You have all that. Now, I'm actually not going to create this because it takes a while. We only have 45 minutes total for this presentation, and I already have one available. So I'm going to go to this one that I have right now. This is a database that I've created. Not this one. Oh, no, I haven't created yet. Excuse me. I'll go back over to here, go to home, and I will find my cluster, and I'll create a new database because that is pretty darn fast right here. Here we go. This is the wrong one. Let me just switch directories here. And that's the one that I want right there. And I'll go down to databases and I'll add a database. I'll call this one RCCDB for Romania Codecamp. And I'll just take all the defaults right there, click on create. And in a few seconds, I will have a database and I can start creating some assets. Like first thing I want to do is to add some tables to it. So there it is right there. When I get rid of it, I can select it and delete it or whatever. But what I want to do is go back up to the query tab, the query blade right here, and let's refresh that. What I want to do, actually, I'm going to open this in the web UI. It's a better user interface right here. And I want to refresh that. I should see, there we go. There's my new database. It's got nothing, no tables, nothing in it. So let me create some tables. And I've got a pre-done script right here to do that. So I'm going to create a table here called drone data. It'll have an ID for the drone. This is just tracking drones flying around the neighborhood, spying on your neighbors and whatnot. It knows where they are, and then it tracks the battery life. So this right here creates the table. And I'll just really quickly jump ahead and show you in Kusto Query Language. If I just type the name of the table like that, it shows me there's the table with no rows in it. If I want to add some rows, here's my ingest inline into table drone data, and then just a comma delimited list for each one of these. So I've got 2 drone IDs, a bunch of different date times. These are latitude, longitudes, and where they are at each date time, and then the battery life, which seems to be going down a little bit as time goes on. Let me create that, and now when I query this, I'll have a bunch of data in here for drone 1 and drone 2, so on. I'll come back to that. Let me delete that, and I have another table that I want to create called customers. This one has name, last order date, year-to-date sales and expenses, and then a city and a postal code, and I'll ingest some data into that. This is the data I have on the slide with all those visionaries on it. Let's do that. So about 10 rows or so of people in here. Customers. You can see there's the data right here. All right. So now I've got some data to work with. And this part of the demo is done. I'm going to query that data using Kusto Query Language. And the reason it's called Kusto Query Language is because it was named after the deep sea explorer Jacques Cousteau, which is why I have a picture of a scuba diver on many of these slides. And it is, of course, spelled wrong because that's how we make things more searchable, so that Jacques won't come up when you search for Cousteau. That's the history of the name Kusto Query Language. All right. Kusto Query Language is very fast. especially for time series data, because by default, time data is indexed automatically inside of ADX tables. Um, it has a bunch of really useful built-in functions. I often, if I'm trying to do something, I came from a SQL background. I worked with SQL Server for a long time, and a lot of times that you'd have to write some special query to do something. Often that query, we don't have to do that because there's already a built-in function in there. And it's also read-only, which makes it safer. If you give somebody access to the Kusto Query Language, they're not going to change the data. It's really just a read-only language. And here's an example of it here. You can see if you're used to SQL, you can see that there's name of the table, there's a filter clause, there's sorting right here. Project tells which columns to output, and then take is show me only if you have a million rows, only show me the first 100 rows, something like that. So that's ideal if you want to combine that with ordering. You can do a top in query for that. So if you're familiar with SQL, this should be pretty familiar to you as well. You should at least be able to read it. If it also has some attributes of Bash because it has these pipe characters, and what that means is that the output of everything before that pipe acts as the input of everything after that. So in this case, it's going to do the filtering first, and once it's filtered, then it's going to do the order by, and then it's going to project. And sometimes that's significant. For time series data, there's some really useful things. Prev and next are functions that are built in that are really nice. If you want to do, for example, I want to know every time something changed, I want to know the value that it changed from the previous row. You can sort by time series data by a time series column, and then add an extra calculated column that says, the current row minus the previous row of this same field, and it'll get you the delta of each one. Same thing with next if you want to look at the future. That's really nice. Also, summarizing by bin is a really useful thing. What that does is if I have with IoT data, often we're sending data very, very frequently. So maybe multiple times a second, we're sending data, and we want to query that information over an entire day. We want to see that, but do we really want to see whatever, if we send it every second, we really want to see 24 hours times 60 minutes times 60 seconds. That's a lot of data just for one day. Maybe we only want to see one row per hour. And summarize by bin allows us to do that. There are other aggregation functions that you can do. You can summarize on a column, for example, but summarize by bin is really useful for time series data. All right, here's an example of it right here. What we've got is, in this case, I'm querying a table, and I want where the timestamp is between this 8 a.m. and 5 p.m. on that date, and I'm using this summarize by bin, and I say, using the timestamp column, I only want one row per hour. Even if I have 1,000 rows each hour, I only want to see one row per hour. And when I say that, your question would probably be, well, which row should I show? And one of the options is that I can just show the argmax. And argmax says, look at that first column, the timestamp column, and just find the one with the highest timestamp, the maximum timestamp. And that's the row I want to show. I want to show the longitude and latitude of that. And that's what this outputs. So you can see the output over here. Even though this data set had many rows per hour, I'm only showing it for 8 o'clock, 9 o'clock, 10 o'clock, 11 o'clock, etc. Every one per hour. And it happens to be the latest latitude and longitude at that point, at that end of the hour. One thing that we used on my last project was geographic functions. We were mapping information on data as it moved around, and there's a lot of built-in geographic functions in KQL that we found really useful. You can, for example, calculate the distance between 2 points. Just give it a latitude and longitude of one point, latitude and longitude of another. It'll automatically calculate the distance. You can determine whether or not a point is in a given polygon. So if you draw a polygon of 3 or more sides, which you can do with the lat long of each of the corners, then you can give it a lat long, and it'll tell you whether that true or false. Is that inside that polygon, or false, is it outside that polygon? And there's also ways of working with S2 cells. And that was a new concept for me, but I'll go into more detail with that later on. But essentially, there are tools to allow you to use S2 cells to convert lat long to S2 cells, or S2 cells to lat long, and a lot of other useful functions. And I'll show you an example of that later to clarify that. But I want to start with polygons. Here's the code for creating a 4-sided polygon. You can see that these 4 points right here are just, there's a lat long of 4 different points, and I turn them into arrays, and then the polygon is just basically an array of arrays of type polygon. That's what we're doing right here. So I have this variable called polygon right here, and once I have a polygon, then I can write a query that says part of its filter is and geopoint in polygon. This is a built-in feature or function in KQL. I'll pass it a longitude and a latitude and a polygon. It'll tell me true or false. Is that inside that polygon? Is this point inside this polygon? And so this one will filter on, show me only the data that happens that is inside of this polygon. So I get something like this, where these devices are only those that are that are inside the polygon. I'm not showing all the ones, and that are of course inside that date range as well. And that's really useful. It's a little bit inefficient. I'll talk about that later but the bottom line is this timestamp function right here, this timestamp field is automatically indexed. So this part happens really fast. This function is not indexed. And so it has to do a table scan. After it does the timestamp, it's going to do a scan, a row scan to do this. So that can be inefficient if you have a lot of data. If, for example, this date time range is really, really large, you may have to filter through a lot to find that. But I'll come back to that when I talk about optimization. The next thing I want to talk about, though, is functions. You can create a function. These are analogous to stored procedures in Oracle or SQL Server. And here's the syntax: create or alter function. We can give it some properties like the document, the name of it. If I want to organize it by folders, just to keep things a little bit better organized, I can do that. Here is the name of the function. This happens to be called device path. These are the arguments that you pass into the function, the parameters, and they each have data types associated with them. You notice that this last one has a default equals 1 hour, and that makes it optional. I don't have to pass in that 4th parameter, because if I don't, it'll just assume that it's 1 hour. And then here's the code itself of the function. This one happens to be doing querying this table on time and device ID and doing some summarization by bin, sorting, projecting out some things, some columns right there. So that's what device path does. So the name of the function is device path. If I want to call it, I just simply device path, and then I pass in the arguments. And here I'm only passing in the first 3 arguments. I didn't pass in. If you look back here, you notice that this 4th one is optional. I'm not passing in that one. So it assumes 1 hour and it outputs data by the hour. This is a function using our geopoint in Polygon right here. So in this function, devices in Polygon, I'm going to filter on geopoint and Polygon, the same thing that I showed on the previous slide. And I'm also going to summarize it by bin of 1 hour. I'm going to roll these things up so I only get 1 row per hour. Now, I mentioned before, this is not really optimal because of this function isn't indexed. And there's really no good way to index that unless we did some, pre-calculation on this, which doesn't really seem very efficient. But there are a couple ways that we can maximize or we can optimize this. All right, one is creating a materialized view. If you're using aggregation in your queries and you find that you're using the same aggregation over and over again, for example, summarizing by bin of 1 hour, it probably makes sense to create a materialized view that does that aggregation in advance. That's what a materialized view does. So here I've got a materialized view. You see, create async materialized view, in which I am querying my table and summarizing argmax by timestamp of 1 hour. And what that does is that every time a row gets inserted into this table, this materialized view automatically gets updated. So there's a tiny bit of a performance hit when you do an insert, but there could be a major performance gain when you query that. So if there's something that you query up by a lot, this would be really advantageous. So if we use this, I've called this one telemetry data underscore 1 hour bin, then we can query this materialized view just like we queried a table. Just pretend it's a table. And now you'll notice that there's no summarize by bin anywhere in this query because that was done ahead of time in the 1 hour bin. And we get the same data back that we did if we had just queried the table and added the summarize 1 hour bin. And this is a big, for large data sets, this can be a big performance gain by pre-aggregating something. Then we don't have to do it at runtime when we actually run this query. The other way we found to optimize the query that I showed you, going with the GeoPoint and Polygon, is using these S2 cells, which I mentioned earlier. An S2 cell essentially takes the world and divides it up into rectangles of approximately equal size. Now, I know these don't look like rectangles, but that's because we've projected the globe onto a flat surface here. But this is a line of latitude. And there are different levels of S2 cells, which is why there are different size cells here. So this one is level 0, which divides the world up into 6 rectangles of about equal size. This is of level 1. This is of level 2. This is level 3. It goes up to, I think, level 33. So level 33 has the rectangles are only a few millimeters apart across, and it takes, I think, 100 billion rows or so to cover the entire Earth, or 100 billion rectangles to cover the entire Earth. Some huge amount of data. So depending upon the precision that you want, you decide what S2 cells you want to use. And so this is a way of finding things that are close together without going to all the trouble of actually calculating exactly where they are. If we have these two are in the same S2 cells at level, I think it's at 3, then we know they're pretty close together, at least at that level. What level we choose depends upon our precision. So we can use this because of the built-in functions in ADX and KQL, and because of our knowledge of S2. So one thing we can do, there's a built-in function called GeoPoint to S2 cells. So if I pass in a longitude and latitude and a level, then this will return the S2 value. And you can see I've in this query, I've actually calculated it for levels 9, 12, 15, 18, 21, different queries or different levels of S2. And you can see at level 9 and at level 12, these are all the same. All these latitudes and longitudes, even though they're different, they're the same S2 value. However, once they get to level 15, they start to diverge. These two are in the same S2, which is the same as this one here. But this is a different S2 cell. So at level 15, you can see we're starting to group together the locations that are close to each other. And how can we use that? Well, let's take an example. Imagine if we have a data set that contains the location of a bunch of vehicles over time. And we want to say, let's write our query, the one we did before. We said, let's filter all the ones for this vehicle that are within this polygon within this time frame. And that works fine. I showed you a function earlier that did that using the GeoPoint in Polygon. But it can be really slow because what happens if the data that's outside of the polygon is way greater? Let's only 0.1% of the data is inside of this polygon. We filter by time and we pick a really large time range. We may not filter much on our time range, and now we've got to do this table scan to do the GeoPoint in Polygon. What if we could overlap that with some S2 values, some S2 cells that completely covered this range, and but no more, just a minimum number of S2 cells that would cover this. Then if we could filter on that first, then that would make our query of S2 of GeoPoints and polygons a lot faster because we'd only have to do a table scan for these. And that would be a lot faster. And that's what we did. So we have here, very first thing we did is we created a materialized view. And in that materialized view, first we pre-calculated the S2 values. I just picked level 15 as kind of an arbitrary value. But I pre-calculated that so that every time a row is inserted, we automatically know what the S2 cell value was. And I also summarized by bin. So with materialized view, you have to do some summarization, but we're doing summarization anyway. So summarize by bin by 1 hour. And then we stored that in a materialized view, which we called telemetry data underscore 1 hour bin. So this is the same materialized view I showed before, except that it has this extra column, S215, which is the S2 value. So that's all done in advance. And now in my function, the first thing I want to do is before I run my query, I want to get an array of S2 cells using this function, geopolygon to S2 cells. I pass in a polygon, I pass in an array, and that will give me an array of S2 rectangles that will just cover the the polygon that I want. So it'll essentially give me this right here. The minimum S2 cells at that level that will cover that polygon. That's what this does. So the S215 array has that. So now I'm going to query my materialized view, which already does the pre-aggregation, already calculates my S215. And as part of my query, I'll say, and S215 has any, which will tell me only those. I'm going to filter on this, say me only those that are inside of this array of cells that covers this. So now this is optimized because this is indexed, and I can query this devices in S2 box data set here. I can query that data set to query, and this will run much, much faster. So we're able to increase our performance by an order of magnitude by doing this. Now, of course, this is more data you have, the more performance gain you'll get. All right, so some things to query optimization, and there's a link down here. I'll share these slides with you later on, but to show all the optimization tips. But materialized views are great. Always want to query on time filters very first thing, because that's what's always indexed. If you can avoid filtering on calculated columns, then those tend to be very slow because there's no way to index on them. Case sensitive, case insensitive parameters or operators are a lot faster. And view more down here. But all right, those are my slides. I want to show some demos here of KQL code. Let me do that right now. It is, let me grab this. Now, remember earlier I created a table called customers. You can see it right there. There's the customers that I created. That's all of them. If I want to filter, I want to show only those where year-to-date sales is greater than, what is that, 100,000. Then I can do that. Let me click run on that. Now I only get these folks, the big spenders here. I can do sorting. Let's run that right here. I'm sorting by postal code. I put ASC. Actually, by default, it sorts in descending order, which confused me a little bit because SQL Server does the opposite. And if for a tie, it goes by last order date. So postal code's over here. West Coast folks are on the bottom, and for ties, there we go, ties, it sorts by last order date. And then here you here's a top end query. I want to know the top 3 year-to-date sales using this take right here. This is a projection. If I don't want all the columns, maybe I only want certain columns, I can do that, and I can do calculations in here. So next day equals last order date plus 1, year-to-date sales, remaining quota equals, let's say everybody wants to do 2 million. This is how much do they have left to get to 2 million. Then I can do this. Calculations are just fine in here. This is right here. Let me do that right here. This is using the extend keyword. The extend keyword happens after the project. In this case, I have to do that because I'm actually doing a calculation on a calculation. So first I do the remaining quota, and then I want to do remaining quota times 2. So I couldn't put that in here because these are all done simultaneously. So I do that, and now I've got, this number is double that number. Let's see. That's redundant. Here's an aggregation. Here I'm aggregating by postal code, and I want to know the average year-to-date sales and the number within each postal code. Something you might do in a SQL language pretty simply. And then these, if you were using SQL, you probably had no trouble following any of this stuff. But if you are familiar with SQL and you want to write the query, there's a really cool thing called explain, in which I can write a SQL query right here and click on add explain to the beginning of it, and it actually shows me the query to run. So that's kind of cool. All right, there's some simple ones here. I've got about 8 minutes left, so let me do some time series data stuff here. Let's go up to the top. Here's the drone data. Remember, this table looks like this. It's got a drone ID. I've got 2 drones here, a timestamp, a location, longitude, latitude, and the battery life, which seems to be dwindling over time. And here, I can combine these things together, order by, project, extend the battery life. Here I'm using the prev function, which is really nice. So if I give previous battery life is this, and now I'm calculating the battery life minus the previous battery life, that lets me get the delta. So I see that it's from 100 to 99. Here, there's the battery life and the previous battery life. It's going down by zero point 0.1. It's usually go down by 0.1. Jumped a bunch right there. Didn't go down at all right there. So this is really useful for delta. This might be kind of hard to write in SQL. Here's an example of summarizing by bin of timestamp every hour. And I'm going to use the arg max of the timestamp right here. There we go. And that outputs 1 row per hour. There we go. Even though there's rows, I think I had row every 15 minutes in there. Here's one where I'm doing some calculation of distance. So here I'm using the geo distance 2 points, which takes 2 arguments. One is the latitude, longitude of one point. The other is the longitude, latitude of the other point. It'll just tell me the distance between the two. You could write a function yourself to do that, but it's already built in here. The distance between this point and that point is, I think it's in meters, 1,600 meters. And here's the code for doing a polygon. In this case, I've created a 4-sided polygon right here, turn each point into a longitude latitude array. And then this is the syntax for creating a polygon of type polygon. And now I can take this polygon right here and I can say, called geopoint in Polygon, show me all the rows in drone data where that point is inside of that polygon, and then sort them right here. And there they are. Of the 20 or so rows, only 4 of them are inside of that polygon. 3 for drone 1, 1 for drone 2. What is this? Here's doing geopoint to S2 cell. I just said row level 30, so it's pretty large right there. So it calculated level, that shouldn't be 30, that should be 13, excuse me. Let's do that. So I calculate, so this geopoint, which I can then use later on in some sort of function. In this case, this is not optimized. This is just using a query where geopoint and polygon. It's not a big deal. There's only 20 rows here, so I don't really have to optimize that too much, but that's the same 4 rows right here. I'm not doing it in a materialized view. I'm actually doing the S2 array here, and then I'm querying that right here. So it's a little bit done right here, but I'm doing this in real time rather than putting that inside of materialized view. But I get the same 4 rows from this as I did without that. This is, I get the point I wanted to make. All right, about 5 minutes left. Let me show you some materialized views right here. Create a materialized view. Backfill equals true is interesting because if I don't specify backfill equals true, it will only start pre-aggregating for data going forward. In other words, after I've created this materialized view. Whereas if I set backfill equals true, it'll take the entire table as it exists now and create the material, add to the materialized view any existing rows. So on table customers, I want to summarize, count minimum year-to-date sales, maximum year-to-date sales, average sales, etc. So let me create that materialized view right here. You can see that it actually shows up in this interface over here. If you like materialized views, there it is right there. And now I can query it just like I was querying a table. There's the rows by, what is it? I forgot what I did. I'm averaging by postal code, the rows by postal code. If I want to change it, let's say I no longer want the average sales, there's an alter materialized view. I'll show that in there. Bang, right here. And those are the demos that I have, and which is good because I only have about 3 minutes left in my presentation. But let me return to my slides real quick. And this is where you can learn more. There is this slide deck right here, including the demos, is available on my GitHub page. So there's the slide deck. These are the demos that I had to create the scripts and the code, the KQL code I showed. This is the official documentation. So I found myself going back to, oh, that's not right. That's actually wrong. I've got them backwards here, I think. Shoot. The official documentation, I'll have to come back to. It's this docs.microsoft.com/hours. So I've got a broken link in there. I'll fix that. What this is a series of articles, that I wrote. I have a blog, davidgiard.com, and I wrote about a dozen articles on how to get started with Azure Data Explorer. And then I also created some videos here. So if you go to one of these videos, it's a YouTube channel. There's been one. Let's do it. I don't know. That's not really. Looks like I have a broken link in there as well. But right inside of here, there's that good looking guy here. If you go to this channel here, I have a bunch of videos here, and the last 8 or so were all on Azure Data Explorer. So look at that, and let's go back to here. And there's a video that Microsoft produced showing off some of the customers that they have. So the only thing I wanted to do is this broken link right here, which I'll fix after this presentation is over. This is the official documentation right there. That's what I meant to do. That's.
Thank you very much, David.
Yep, that's my presentation with 1 minute to spare. I've never hit it that closely before. Shift F5 to get my.
Well, yeah, and we're going to have a couple of questions. And the first one would be where Data Explorer fits into the overall Microsoft data platform or data offering. How do people usually use it? That's
yeah. So
thing.
great question. This article right here will help answer that question. So that flow chart is a really good place to start. I totally stole that from here. And here's the idea: when do you want to use it? The short answer is if you want massive amounts of data, like petabytes of data, and you want to be able to query it in near real time, and it's you're working with structured, semi-structured, or unstructured data, or all those things, then Azure Data Explorer is for you. If you want to do things like lots of reads and writes, you want to go back and edit data a lot, that's probably not the best solution. Whatever. If you need your database to run on multiple clouds, that's probably not the best solution. If you run something with built-in ETL, there's other options. So it's kind of optimized for one thing: lots of data ingestion, huge storage. Well, not one thing, but a few things: huge storage, near real-time querying. If you wanted the star schema, data warehouse is probably better for you.
Mm-hmm.
So this actually talks about that quite a bit.
Mm-hmm.
This article right here, which I have in my slide deck.
Mm-hmm. For data ingestion, data integration, one popular service and tool nowadays is Data Factory,
Right.
and there is a integration between the two.
Absolutely,
Right?
yeah. So if you wanted to have as a data factory a destination for your data, you want to do some workflow ahead of time, then before you ingest it, Data Factory would be for you, and you could ingest it into ADX.
I've heard people discussing about Data Explorer and Elasticsearch or OpenSearch or similar. I mean, in the in this space of searching and large amounts of data and searching over this data, what would be like a similar tool? I mean, if you want to compare Data Explorer, what is the service that you're comparing with? Is it Elasticsearch? Is it a different thing?
I don't know. I mean, this solves a unique problem. We just want to dump lots of data, like for log files, for example. It's really good. But this is the tool of choice for that. If we don't need lots of workflow, we just want to have a data store. In the past, I probably would have used something like a data warehouse for this, but data warehouse doesn't have that near real-time querying, and it's a little bit slower because there's some schema for relationship enforcements on it as well. However, it's more flexible. So this is positioned. I mean, this was a need that for this particular set of needs, that tool didn't exist, and so that's why it was created.
Mm-hmm.
So, I mean, there are a lot of tools. There are a lot of large, massive data tools that'll just store a lot of data and allow you to query them. And they're some from a lot of vendors. This is the one that if you really just storing and retrieving, and then you've got a lot of time series data, or you've got use for. I mentioned the geo functions. There's also a bunch of machine learning functions in here. If you want to make that part of your query, you can do that as well.
In the weather Azure ecosystem, I saw it being used for monitoring, log monitoring, and then similar things.
Absolutely. So anything with like log files, monitoring is basically you're just grabbing information on the fly and just shoving it in because you might need it later on. Somebody wants to query it later on. It's ideal for that because it is so fast and it is so scalable.
All right, David, thank you so much once again for the talk. It's been very insightful.
Oh, thank you.
We're looking forward to having you back in Romania at Codecamp.
I look forward to coming back.
We shall see when all is come to a fortunate end. And yeah, of course.
Dan and
Okay.
Florin, where are you physically right now?
In our office in Iași.
Yes, okay. I have not been there.
We'll be sure to invite you next time.
I would love to. I've been all over Transylvania and I've been to Bucharest.
Next hop will be here for sure.
I hope so.